Hi, my name's Dan, and this video is one in a series of videos that I'm doing on developing multiplexers in digital electronics. I'm using simulation software called DigitalWorks. It is a free piece of software, and there's a link to it in the description below. And this short set of videos is part of a much larger set of videos which are charting the process and progress from basic logic gates all the way through to a 4-bit CPU. And so that's the wider context of what I'm doing. If you want a roadmap for that, that is also down in the description below. So you may have picked this one up at random out of the other videos. You may have just picked up this short series of videos on multiplexers, which will be a playlist, or you may be following on the whole thing. There will be things in this that you need prior understanding for. I'm not going to apologize for that, because the whole of digital electronics is a kind of a pyramid of knowledge that you build up. So where are we? We've done a two-way 1-bit multiplexer. We showed how to expand that out to make a 4-bit two-way multiplexer. And basically we're going to develop a couple more multiplexers because they're going to be useful later on in our CPU design. So the next one that we're going to do, this one is going to be 1-bit again, but we're going to do a 4-way. So that means we've got our control signal, which is a binary input number, needs to be 2-bit. And there are 4 possible inputs. The control signal will choose which one of the 4 inputs is routed to the output, and there'll be the one output. So we're going to use the 2-bit decoder that we had previously, which is going to help us do the choosing. We could have drawn that out again, but there's no particular reason to, because we've already got the circuit. Let's just remind ourselves of what's inside here. And it's just a basic, you've got your binary input lines, and you've got your AND gates, which pull off there to choose which binary number enables any particular output. Let's close that macro. So we've got the 4 lines that we've got is going to be an input. We're going to stick a couple of tags on there to be our control input. Where's that not giving me another one? There we go. Let's quickly annotate that. I'm going to call it control. And as normal for binary numbers that are done vertically, we're going to do it that way around and rotate it so the most significant bit is at the top there. So that annotation's on its side because it makes it clearer what's going on. And we're going to have 4 inputs, and am I going to collect them together, or am I going to just do them close to the gates? I'll do them close to the gates because it makes this a bit clearer. So I'm going to need 4 AND gates, 1 for each of our 4 inputs. I'm just going to put them a bit below so that I can use output lines from this decoder to go into them, and I'm going to use Control C and Control V to create a copy of that gate, and let's get it lined up. And highlight the 2, Control C, Control V again. And then we need to take the outputs from those, and we're going to turn that into a 4 input. And it re-rotates it. I'd forgotten it does that. And so I'm going to start wiring this up. So if you remember the principles, if you looked, if you've seen some of the early videos on multiplexing, then you've basically got 3 components for a multiplexer. You've got binary decoding for your control on the input, which is what this macro here is doing. You've got one AND gate for each of your inputs, and the 4 outputs from your, in this case, 4 outputs from your binary decoder go into one of these each, to choose which one goes through, and then the 4 outputs from the AND gates are put through as many OR gates as you need to make sure it can be, whichever signal has been selected gets routed through to your singular output. Now let me check the numbering of this. So this is output 0 at the bottom, so I want 0 to be on the right hand side. It's always worth checking with binary numbers that you've got the orientation correct. Nearly there. Right, and that should be it. And what I'm going to do is then open the template editor and turn this into a macro. First thing I'm going to do is change this annotation. So it's not 2-way 4-bit, it's 4-way 1-bit. And instead of having that many pins on the input, I'm going to only need 4. And so I'm going to, instead of calling that A1 3 to 0, I'm going to call this A. And which way are we going round? We've decided that 3 is the leftmost end. So actually this is, that's potentially not the way around that we want them. We probably want them to go 0 at the left and 3 at the right. I could rewire this whole thing, but I don't need to. All I need to do is to make sure I get the connection between these tags and the pins on the template correct. So I'm going to do A0, A3, and then be careful when I do my wiring up to make sure I've got it the right way around. I'm going to shuffle that stuff across. Now control these 2 pins instead of 1. So let's get a second pin there, and we're just going to raise those 2 pins up a little bit. Excuse me. Now we've got this on the main circuit, so that it's control 1 to 0, and I'm going to reflect the fact that that was rotated there to be the same way around, and that would be normal. And we only need 1 output, so we can remove some of those pins and edit that so it just says output. I'm going to edit that again so it actually has the T on it, because I'm not quite sure what an output is, or I don't really want to speculate as what an output really might be. Just a bit more tidying up. At this point I could speed up and play you some music, but there's not that many to do, so if you want to speed it up yourself, feel free. Otherwise, I'm just going to connect up these pins. Those pins don't stick out very far from the template, so they're quite hard to select. Template editor, so which is why I'm using boxes to select instead. And we've got now. I remember I said something about this. So this is input 3. So I need it to be that end. And going across the other way, so I'm reversing the order. If I'd wired it up the other way around, then that would have also been fine. As long as we're clear what's being connected to what and how we're ordering it. then we're fine. Nearly there. Well, if I can select it, that would be good. One to go. And let's save it. So save as, this is mutex, and it's, no, I've done this again. When I see the word MUX, I say the word mutex, which is a different thing entirely. And it's 4-way, but it's 1-bit. So if we wanted to make a 4-bit 4-way, it'd be fairly straightforward to chain, obviously, 4 of these together to do that. But we're not actually going to do that. But what we are going to do is we're going to create a test circuit just to check our 4-way 1-bit. And so we've got 4 inputs. 1, 2, 3, 4. Not bothering about lining up. 2 control inputs, which determine which one of the inputs goes to the output, and we'll have an LED on the output. And again, just a little bit of wiring to do. And I hope you've been playing along with me so that you'll have one of these created yourself, so that you'll be able to see it working. So I've hit simulate. So at the moment, our control input is 0, 0. So that should mean that this left-hand end one is the output that's being routed. And I'll just flick that on off a couple of times. And what I'll do is I'm going to flick on and off the others, just to check that they're not influencing. And go back and verify that. And then I'm going to pick, so that's going to be 2. So it should be this one here. That is incorrect. It's that one. Okay. Now what's happened there? That should be right. Let's be clear about what's going on here. That is 0, and that is input 0. That should be 1, because it should be the least significant bit. And that goes to, does it connect with that one? So that's connected to A2, not A1. So I think it's possible that these bits are the wrong way around. That should be 3, so it should be the end one. And that is correct. Okay, let's have a quick look inside this macro we created. Right, and we can see that I have got this kind of twisted, because I've got written here control 1 to 0, which would imply that the upper one is 1 and the lower one is 0. And in fact, what I've got here is inputs 1 to 0 written the other way. So that's 1 and that's 0. So this is, a good reason for us to do this testing, is that actually I've got those 2 flipped. And so what I'm going to do is I'm going to go back into loading the macro up and fix this problem. So this, okay, you've caught me out, I made a mistake, but actually it does demonstrate the fact that the process of testing that I do at every single stage is important, and it's worth doing this. So let's open that circuit back up. I'm not going to save the current circuit. I'm not actually going to retest because I know what the problem is. So it's the 4-bit, sorry, the 1-bit 4-way, and it's connecting. I can fix this by connecting it differently in the template editor, but to disconnect is a bit odd. So I'm just going to need to actually delete one of these tags, and in order for to make this right, this is why I had a problem. It's because I rotated this the wrong way. And I imagined binary numbers go from top to bottom. And they do normally when you're designing something top to bottom. But what I've done is I've taken something that goes left to right and turned it on its side. And that's effectively put it the wrong way around. Let's, for the sake of making this slightly easier, just get rid of both of those tags. And then we'll need to put 2 tags in. The reason why I'm deleting them is because I don't know if there's any way of disconnecting the tags from the pins in the template editor. Excuse me, but if there is, I don't know how. So this is the way that I know how to do it. And so into the template editor, so you'll see that these control 1 to control 0 have been disconnected, and I need to make sure I wire them the opposite way up from how I had it. So let's stop simulating. So which one have I got? I've got 1, control 1, which is the most significant bit, which is actually here on the top. So see the tag. Now I'm going to be lazy and not do a further test because I found this problem and I have fixed it. I believe it to be fixed. If you're not sure, then I suggest you go through the process of testing it. This might bite me later on. Excuse me, when I try and use this component if it's not wired up correctly. But I'm going to be lazy and do that. Okay, so that's it from me for now.